All right, everybody. So go ahead, update your table of contents. Today is the 4th, and we're talking solving by graphing. As a reminder, the 6 weeks does end this week on Thursday. Thursday is the last day to turn in any late missing work, retests, anything like that. All right, so our goal today is to be able to identify solutions to a system of equations by graphing. So first, let's kind of review some things we talked about yesterday. One thing we talked about is what a solution is, that a solution is the point where two lines intersect. Well, here's the thing. What if I don't have a graph and I can't just look at the graph to decide if a point is a solution? What if I only had the two equations? How could I do it? Well, in a coordinate, we know we have an x and a y. So if we don't have an x and a y, and in our equation we have an x and a y, we can just replace that x and y in our equation and see if it gives us a true statement. So for instance, here on this equation, I can see if 2 equals 2/3 times 5 minus 3. Okay, so that right there is what I would put into my calculator. So in my calculator, we're going to do 2 divided by 3 times 5 minus 3, and that gives me 1/3. Is 1/3 equal to 2? No. And right there, I would figure out, well, if it's not a solution there, then it's not going to be a solution for this system. All right, so now let's try it on this one. Same thing. Let's replace our x and our y. Okay, -3 plus 1 equals -2. Well, if I put this into my calculator, -3 plus 1, I see -2 equals -2. That is a true statement, which means if it works for this one, I need to see if it works for the second one. If it doesn't work for the first one, that's when I can stop. All right, so -2 plus 5 times 1, -2 plus 5 times 1 is 3 equals 2. Does 3 equal 2? No, it does not, meaning this is not a solution. Okay, it would have to work for both. If it doesn't work for both, then we don't have a solution. If it does work for both, then we do have a solution. All right, so now, what if they don't give me the solution? How do I find it? Well, the way we find it, one way by doing this, is by graphing. And we started kind of introducing this yesterday. So, how do we graph two equations? Well, looking at these equations, what form are they in? They're in y equals mx plus b. If they're in y equals mx plus b, that means I know my slope and I know my y-intercept, which means I can go ahead and graph this equation using those two things. My y-intercept is 0, 1. I'm going to plot that point. Then I'm going to use my slope of 2, 1, 2, 1 to get the rest of my graph. You want to go ahead and make a sketch of this in your notebook and make notes of how we are creating these graphs. Okay, so there are my points for that line. Now let's do the next line. I have +9 is my y-intercept. I got -2 is my slope. So let's go to +9. And then this time I'm going to go down to left 1, down to left 1, and keep going. And that's about good because right there, right at this point here, I notice both of my lines have the same points. Now notice I'm not just leaving these as dots, I'm going to go ahead and connect them so I know that I actually have two lines. But really what I'm focused on is this dot right here on what that coordinate is. that coordinate, if I go down to the x, is 2. If I go over to the y, is 5. And that would be my solution. If I put it in both equations, I would see 5 equals 2 times 2 plus 1. And 5 equals negative 2 times 2 plus 9. Both of those would end up being true statements. Okay, now you guys try this one. Pause the video and you guys try it. All right, I'm going to go ahead and do this. So I got 1, 3, negative 3 is my y-intercept. 1/2 is my slope. So I'm going to go up 1, right 2, up 1, right 2, up 1, right 2. Okay, so there's that line. And then my other one, I have a y-intercept there, my slope there. So my y-intercept is positive 2. So we're going to go down 1, 1, 2, 3, down 1, 1, 2, 3, 1, 1, 2, 3. And since I went ahead and I already intersected, I'm not going to keep graphing because this right here is the coordinate that I'm really focused on, which is 6, 0. And if I checked, I would see 0 equals 1/2 times 6 minus 3. And then 0 equals negative 1/3 times 6 plus 2. All right, well, what if both of our equations aren't in slope-intercept? What if one of them is in standard? What would we have to do then? Well, in standard, I cannot identify anything, but I can change this equation from standard to slope-intercept. So how do I do that? I need to go ahead and subtract x from both sides. So I get 2y equals 6 minus x. Divide everything by 2. And I'm going to get y equals 3 minus 1/2 x. Okay, again, you must change this equation in order to be able to identify your slope and your y-intercept. Because now I can see my slope is negative 1/2. My y-intercept is 3. And now I can go ahead and graph this. So y-intercept of 3, and then down 1, 1, 2, down 1, 1, 2, and I'm going to keep going until I get my entire line. And then I'll go ahead and do this other one. My y-intercept this time is 2. My slope here is negative 1. So positive 2 is my slope, and negative 1 is my y-intercept. So notice, as I went down, I never ended up getting a point, but if I go back up, I do right here get my point, and that's going to be negative 2, 4. All right, now you guys take a try at this. All right, so I need to change my equation up top here into slope-intercept. So I would need to subtract x from both sides, and that's going to give me negative y equals 6 minus x. divide everything by negative, and I'm gonna get y equals -6 plus x. So that means that my slope is 1, my y-intercept is -6. And on the opposite end, I have a -1 y-intercept, and then a -1/4 for my slope. Okay, right here, I see my y-in, my intersection, my solution is going to be 4, -2. All right, guys, we're gonna finish this in part 2 of this video.